DNS Records. Before we get stuck into the common types of records that you will create on a DNS server, we'll start with the service records. Service records are essential to Active Directory. They let DNS know what servers handle different types of services. In other words, a service record tells DNS that if you're looking for a particular type of server that handles this particular service, then it's over there. Service records, or SRV records as they're also known, lets DNS identify servers that run a particular service, reside in a particular domain, or use the TCP or UDP protocols. Once a service record has been retrieved, it tells DNS the name of the server that meets the criteria of the request. It also tells DNS what port is needed to contact the server. And because service records allow you to specify multiple servers, you can also give different servers different priorities. So for example, when you attempt to log on to an Active Directory domain, DNS will attempt to locate a domain controller for you to log on to. DNS uses these service records to identify which servers are acting as domain controllers and then responds to your logon request with the appropriate domain controller's details so that your client can log on. Now, if you do want to know what type of services are available, there's a list of common services in a text file stored in the Windows System 32 drivers/etc in a file called services. Okay, so let's go and take a look at a service record to get exactly an idea of what I'm talking about. The first part of a service record lists the service for the record. So in this case, the record identifies that this server is providing the LDAP service. The service is always prefixed with an underscore and can contain such common services as SMTP or Telnet to help DNS locate email or Telnet servers. The next requirement of a service record is to join sections with a period. After all, this is DNS we're talking about and everything is separated by periods. Then we have the protocol. In this case it's TCP. So we know so far that to contact this LDAP service we need to talk to it using the TCP protocol. Now next we have the name MSDCS. We also have a value of 600, which is the time to live for the record. So this basically says, well, if you look up this record, you can cache it locally, but you'll only be able to do that for 600 seconds or 10 minutes. After that, you'll have to come and get it again. And next we see the record type, which of course is an SRV or a service record. Now the two zeros that follow this are referring to the priority and the weight of the record. The priority can be a number that ranges from 0 to 65,535. Now the lower the number, the more priority given to the record. So for example, let's say we had two service records pointing to two different servers. They had the same service running, and one had a priority of 10 and the other had a priority of 100. Then the client would be directed to the server listed in the service record with the value of 10. If that server was down, then the client would be redirected to the other server. The weight can also be used in addition to priority to provide a load balancing mechanism where multiple servers are specified in the target field are all set to the same level of priority. So when selecting a target server amongst those of equal priority, the weight can be used to set an added level of preference that can be used to determine the exact order for the target host used in an answered service query. So when a non-zero value is used, servers of equal preference are tried in proportion to the weight of this value. Now the range of values is from 1 to 65,535. If load balance is not needed, you use a value of 0 like we have here in this field, and it makes the record easier to read. Now next we have the port that the service will talk on. So for this record, LDAP is using TCP. It has 10 minutes that we can cache this record for, and to talk to us, you're going to have to talk to us on port 389. And of course, finally, we can see the name of the server, or the target if you like, that the service is located on. So in this case, to talk to LDAP on port 3389 using TCP, you're going to have to contact server01.testdomain.com. Now whether or not DNS is actually installed on your domain controller, there's a file called netlogon.dns which will be stored on your server. It contains a list of all the service records that are required to support the use of Active Directory. So if you navigate to your Windows System 32/config directory, you'll see the file netlogon.dns, and we can simply right click and select open, and we'll open this as it is a text file with Notepad. And now you can see a bunch of records in here that by now would probably look a little bit familiar. So if we go over to our DNS MMC, we can see a few folders over here which are all prefixed with an underscore. The first folder we can see is this _MSDCS. This folder keeps track of all of the domain controllers in your forest. Now this is what's known as an application directory partition, or rather it's a forest application directory partition in this instance. Now inside this folder we can see the alias records, which contains the globally unique identifier, or the GUID, for the names of the domains. Now using this GUID is why we can use some of the newer features of Windows 2003, like the ability to rename domains, because some clients might not be able to find the domain if it's renamed, but DNS knows about it by referencing this GUID, because even though the name might change, this GUID stays the same. Now let's take a look under the sites directory, and we'll expand this out here. We'll just expand this so we can view it a little bit easier. Okay, so under _sites we actually have two folders, a default first name site and the _TCP folder. Now this default first name site directory is linked in with the sites that we create in Active Directory. This is kind of out of scope for our DNS videos, but more of what you see in our Winstructor sites and replication videos. But if we open up Active Directory sites and services by clicking on Start, Administrative Tools, Active Directory sites and services, we'll just expand this here, and you can see we do have a default first name site. So what I'm actually going to do here for the moment is I'm going to right click and rename this, and we'll call this US. And we'll close this down. What we're going to have to do now is actually close down our DNS console and reopen it again to be able to see the change. We'll go back into our forward lookup zones. We'll expand our sites, and now we can see that this has actually changed to US. Okay, now if we expanded it out, we can look in our _TCP directory, and we can see here we have 3 records inside. Now effectively what's happening here is that clients that are connecting to our US site, when they contact a DNS server to find a global catalog server to log on, or a Kerberos server, and so on and so forth, DNS will look inside the US site for that client and see the service record telling it where the server is. So in our case, DNS would go back to the client and say, hey, if you want to log on, go and talk to server 1, because that's the global catalog server, and you can do that here on port 3268. So under our MSDCS folder we have 4 subfolders. We have DC domains, GC and PDC, and we'll go through quickly and just explain what they actually do. The DC folder here simply allows us to locate domain controllers in our sites. Now this is exactly what we just spoke about before. Underneath here you can see we do actually have sites listed, and of course we have US. If we had multiple sites, for example we say we had London, we had Paris, we would also see these sites listed under here, and this is just a forest-wide pointer, if you like, to all of the services that are available under our individual sites. Now down here we see a domains folder. Again, it holds service records for the domain controllers that we have in our domain. So if I expand this one out here, we can see with the 2 GUIDs of the 2 domains that we actually had. If we go into one here, we can see this is server 02 in the sales.test.com domain. Now this one here, of course, will be server 1 in the testdomain.com domain. The GC folder is very similar to the domain controllers folder, although this one here is what DNS uses to find domain controllers that hold the global catalog. So again, if we expand this one out here, we can actually see a service record for the global catalog server in our organization, which happens to be on server 01. And of course, to talk to the global catalog server, we need to use LDAP on port 3268. Now finally we have the PDC folder. Now this particular folder here is what tells us which server holds the PDC emulator role at the root of the forest, and you'll only should expect to see 1 service record in this folder. Now we do have a couple of other folders down here, and I'll quickly touch on those. The TCP and the UDP folders simply hold all of the service records for services that run on either the TCP or the UDP protocol, irrespective of any site they may be in. Now the domain DNS zones shows us all of the sites in our domain, and the forest DNS zones shows us all of the sites in the forest. So basically all of this really here is really showing us all of the same information, but it's grouped by different categories. So in other words, we do see things grouped by domains, we see things grouped by if they are a global catalog, whether they hold the PDC emulator role, whether they talk on TCP, UDP, so on and so forth. Now under our TCP folder we can see that we currently have 4 records that use the TCP protocol. So I'll go through and explain what these records actually do. The GC record here identifies a global catalog server. The Kerberos record is used for authentication purposes. Now the K-password record allows a user to locate a Kerberos password change server that conforms to the Kerberos change password protocol. And then of course there's LDAP, which is needed to talk to Active Directory. So if we take a closer look at one of these records, in fact we'll look at the Global Catalog Service record, we can see that it has a priority of 0, a weight of 100, and that it talks on port 3268. If we wish to edit any of these properties, we can simply double click on the record and then we can change some of the properties if we wish. We can also see which host is offering this service. On the Security tab, we can use the Windows Access Control List to control permissions to this object. Now by default, only members of the administrators, the domain and enterprise admins, as well as the enterprise domain controllers groups have the ability to change these objects. So if we sum up what this whole _MSDCS folder is about, it's a single location that allows us to find servers that perform certain functions anywhere in our forest regardless of domain. Now this is really useful because if I'm traveling type of person and I'm in the US but tomorrow I'm traveling to London, then when I get there I need to find a domain controller to log on. Now it's this folder that makes that all possible. The one final thing I want to talk about before we move on to discussing some of the other records is what to do if this _MSDCS folder isn't created. Now by default it is created when you create your first primary zone. Now if your first DNS server has been created on some other DNS system, then this might not be created and you'll have to do that manually. So what you'll do is you'll right click on your forward lookup zones and you'll select New Zone, and then of course you'll select Next. Accept the default of primary zone and store the zone in Active Directory and click Next. Now this time we would actually choose the top option to replicate our data to all DNS servers in our forest of testdomain.com. So we'll do that, we'd click Next, and now what we'd do here is we'd enter the name of the zone, which would be _MSDCS.testdomain.com or whatever the name of your forest root is, and then we'll just click through the remainder of this wizard and then we'll be done. Okay, so I'll cancel this. Now with service records out of the way, let's take a look at some of the records that you'll expect to see inside your forward and reverse zones. So the first thing we can see here is the Start of Authority or SOA record. Now this indicates the name of origin for the zone and contains the name server that's the priority source of information about the zone. It also contains some other basic properties of the zone such as the versioning. Now over here on the right we can see that it starts with a serial number of 106. Now when we make changes to our zone, secondary DNS servers will compare their version number with this one to determine whether or not they need to update their records. So on our secondary server, if our secondary server had a value of say 90 compared with this one which has 106, it would indicate to our secondary server that 16 changes have been made to our primary DNS zone, so we need to start replication to make sure that our secondary is now up to date. So if we double click on our Start of Authority record, this takes us to the properties of our zone and directly to the Start of Authority tab. Now here we can see the serial number that we looked at a moment ago of 106. Now if we wanted to force replication on this, we could actually just click this increment button and increment the number of our serial number. Now next we can see the name of our primary DNS server, which as expected is server01.testdomain.com. Now you might notice that our server name has a trailing dot after it. In fact, this dot that we can just see just here. Now if you want to be technical, DNS to be a fully qualified DNS name actually requires this trailing dot. Now if you recall when we discussed DNS resolution, that test domain was delegated to us by Network Solutions who own the .com, and then .com was delegated by ICANN who managed the root. So to have a full DNS name, technically we must go all the way back to the parent, which is the root, and hence the reason for the trailing dot. Now in most situations we don't ever see or have to enter this trailing dot, like when we ping anything or open a web page, but DNS does use it behind the scenes. Now next down here we have the responsible person. Now even though this actually doesn't look like it, it's actually an email address. The only difference here, of course, we don't have an @ symbol here, we have a dot. Now the reason for that is that the @ symbol is not a valid character in DNS, so it's replaced with a dot. So the default is set to hostmaster dot whatever the rest of your domain is, .testdomain.com in our instance. But of course we can change this if we wanted to change it to say webmaster or something like that. But again, to be complete and valid with DNS, we see the trailing dot again at the end of our responsible person. Now next down here we see the refresh interval, which defines how long the secondary servers will check back with this DNS server to see if there's been any changes. So any secondary DNS servers will check the serial number as we mentioned before. If there have been changes, then it will initiate a zone transfer and pull the records to the secondary. Now if there are any problems with performing a zone transfer, then it will retry after the interval specified here, which defaults to 10 minutes, although we can certainly change that if we wish. Now if the secondary is unable to contact this server for a full day, then its copy of the zone will be expired and it won't be used. If the secondary then contacts this primary successfully, then it will reactivate its copy of the zone and then perform any necessary zone transfers. And next we see here is the time to live, or the minimum time to live, and it's currently set to 1 hour. Now this means that when a client successfully resolves a host name using this DNS server, the DNS server will cache the name and IP address for a total of an hour before it expires. Now finally, for the start of authority record itself, it's also going to be kept for 1 hour, although again we can change that if we wish. Well, the next thing we'll do is take a look at the name server record. So we'll cancel this one out here and have a look at our name server record. Now the name server record is used to notate which DNS servers are designated as authoritative for this particular zone. Now here we can actually see that it defaults to server01.testdomain.com as being the name server for this zone. If we double click on this, it'll take us straight to the name servers tab on our testdomain.com zone properties. So we can see down here that server01.testdomain.com is the name server which is listed as authoritative for our domain. If we did want to have a secondary server that would also be authoritative, if we had 2 or 3, we can simply click on add and then punch in the fully qualified domain name, hit resolve, it'll pop the IP address down here, then we can click add and OK, and then we can have multiple name servers. Okay, so the final thing I want to look at here of these 3 records is the host record, or the A record. And this is definitely the most common record that you'll be creating. A host record simply associates a host name with an IP address. So the first record that our DNS server will know about is the IP address of itself. So it knows its name is server01, so it instantly associates itself with its own IP address. Now in our network, we actually have a router which is defaulted to 192.168.0.1, and unfortunately we can't actually ping that by name, and I'd kind of like to. I don't really like typing in a lot of these IP addresses all the time. So what we can use a host record for is to give this record a name. So what I'll do is I'll right click and I'll select new host. Now I can simply punch in a name and I'll call my router router. And you can see down here it populates automatically with the name router.testdomain.com. And now I can actually punch in an IP address of my router, which is 0.1. And what I'll also do is create a pointer record, and I'll talk about this in a moment. And then we'll just simply click on add host. And we can see that the host record of router.testdomain.com was successfully created. So we'll click done and we're closed. Now we'll open up a command prompt, and now all I have to do is type in ping router, and you can see that it actually resolves the name to router.testdomain.com with the correct IP address. Now the next type of DNS record we have is the MX record, or the mail exchanger record, and it's used for, you guessed it, identifying email servers. Now when you send an email to say bob@testdomain.com, you've told your email client that you want to send an email to someone who has an account named Bob on a server in the testdomain.com domain. What you haven't told your email program is what server Bob's account lives on. Now with web servers and FTP servers, there's an unwritten rule that says that web servers and FTP servers should start with a www or an FTP. While this isn't exactly written in stone, of course, but when you point your browser to a website, you simply expect to type in www.somethingorother.com. Now with email servers, there's no such rule, so an MX record is what tells DNS where to send our email. So to create an MX record, we'll simply right-click like we've done here, and we'll select New Mail Exchanger. Now in the first field here, we need to add a host or child domain. Now in this case, as we want our mail to be in the testdomain.com domain, we can actually leave this field blank. Now down here we need to enter the fully qualified domain name of an email server. Well, we don't actually have any email servers in our network, but that's okay. It won't stop us from configuring an MX record for our demonstration purposes anyway. So what we'll do is we'll enter a fictitious email server of mail1.testdomain.com. Now in the priority field we have a default value of 10. With this server being our only mail server, this box really has no effect. But when we have multiple servers, the priority comes into play. Basically, the lower the number, the higher priority. So we'll leave this default and we'll click OK. Now you can see here that our MX record has now been created. Now we still need to add a host or an A record for the Mail1 server as well. Now we'll do that, we'll right click, we'll select new host and we'll type in the name of Mail1 and we can see the rest of it gets populated here automatically. And then we'll just give it an IP address of 192.168.0.99. Now I realise that that one is not taken IP address on my network, so we'll just click add host. We can see it was created successfully and then we'll choose done. Now what I'm actually going to do here is I'll right click again and I'll choose a new host and I'll call this one Mail2 and I'll give this one an IP address as well of 192.168.0.98. We'll choose add host. It's created OK. We'll choose done. Now what I'll do again is right click and I'll choose a new MX record. This time we don't need to fill in the host or the domain name. We've mentioned that before. We'll type in mail2.testdomain.com. Now of course we have our mail priority of 10, where this time we'll change this one to 100 and then we'll click OK. So now you can see we have two host records here, Mail1 and Mail2, which point to our email servers, and we have two MX records as well, which also reference our hosts. So now, in effect, because we have two email servers, Mail1 will be given priority as it has a lower number here, a lower priority number. So what this really means is that unless Mail1 happens to be down, Mail2 should never receive any email. Now if we wanted to, we could add a third MX record and give it the same priority as one of our other servers. In fact, we'll do that now. We'll right click, we'll create a new host and we'll call this one Mail3 even. And then we'll type in an IP address 192.168.0.97 seems to be the next logical number. We'll choose add host and we're done. Then we'll right click, we'll choose new MX record, we'll go back down here, we'll type in mail3.testdomain.com and we'll leave the priority at 10. Now you can see that we actually have an MX record here for Mail1 with a priority of 10 and we have an MX record here for Mail3 with a priority of 10. So which one wins? Well, actually I haven't tested this, but the general consensus is that both of these two will load balance and that the first request will go to Mail1 and then the second would go to Mail3. Now as I said, I haven't actually tested this configuration, but I thought I'd point it out just in case you happen to be in the lab and you're really bored and you'd like to test it out. Okay, so the next thing we'll move on. The next thing we'll look at is the Cname or the alias record. Now this is where our common www or FTP that we spoke about earlier comes into play. So let's say that we want our fictitious mail server, Mail1 here, to become a web server as well. Now as it stands, internet users would have to type in mail1.testdomain.com in their browser to get to our website. Well, that's no good because people expect to type in www.testdomain.com. So what we need to do is provide an alias of www to our server. So let's do that now. We'll right click and we'll select new alias, which is a Cname record. Now because we want people to log into our server using www, we need to provide the alias name of www. And you can see here the fully qualified domain name then becomes www.testdomain.com, which is what people expect. Now here we can type in mail1.testdomain.com and then we can click OK. And now we see we do have a machine that's referenced as www, which is an alias for the machine which is mail1.testdomain.com. So now when people browse to www.testdomain.com in their Internet Explorer, they'll actually come into our network and hit our mail server, which is also being configured as our web server. Now the same applies if we wanted to do for, say, FTP. We'll right click, we'll select new alias, and we'll call this one FTP, and we can see the name changes to ftp.testdomain.com. And we can of course also put this on the same server if that server happens to be hosting FTP. So we'll choose mail1.testdomain.com, we'll choose OK, and now we can see that we have three ways of actually referencing this server. We can reference it as mail1.testdomain.com, we can reference it as www.testdomain.com, and also ftp.testdomain.com. Now, a couple of points I'd like to make about aliases. You cannot have more than one alias of the same name. So in other words, we can't have an alias of www pointing to mail1.testdomain.com and then create another one www and then point it to mail2.testdomain.com. Now, but we can add more than one alias to a host, as we saw when we created www and FTP for the same host. So now what we'll do is we'll open up a command prompt and we'll type in nslookup ftp.testdomain.com, and now we can see that, okay, our DNS server here has resolved this request, but we can see the name of the actual server is mail1.testdomain.com. It comes back with an IP address of 192.168.0.99, but the alias here for this server is ftp.testdomain.com. And of course we can certainly do the same thing here if we replace this FTP with a www, and we can see that mail1 of course has come back as the same server. Okay, so what we'll do now is we'll close this down, we'll right click and we'll take a look at some of the other records that we actually have. So we'll choose other new records, and we can see that there's actually quite a few of these records in here. Now some of these you won't ever use, some of them are relatively new and others are largely experimental, but for completeness I wanted to go through all of them. The first one we have here is the AFS database. Now to create an AFS database record we can simply click on Create Record, and we can see that we'd enter in a server name here. Now under the server subtype button we can enter a value of 1 or 2. It defaults to 1, which is an AFS server version 3. If we type 2 in this field, it identifies a DCE authenticated server. So we'll click cancel, we'll go back here. We've already seen the alias, we've looked at that before when we created our www and FTPs. Now the next one is the ATM address. Now this maps a domain name to an ATM address. The ATM address can be specified in either E.164 format, which is decimal, or NSAP format, which is hexadecimal. Next we have the host record, and of course we've discussed that in rather a bit more detail, and of course that is the majority of time the most common record that you're going to be creating. Now underneath that we have the host information record. Now the host info record provides a brief description of the hardware and software used by the specified host in the record. Now currently there aren't any systems really that make use of this hinfo record. So if you do look up RFC 1700, you can get a list of the format needed for this record. So I'll click Create anyway, and you can see we actually have 3 fields. We have the host, we have a CPU type, and we have an operating system type. For our host, if we were creating an hinfo record for this particular server, we'd enter server 1 here, and we can see that server01.testdomain.com is automatically populated. Now the next field is the CPU type. Now in some implementations of the hinfo record, this is often referred to as the hardware type. Now here we'd need to enter a name of up to 40 characters, which must be uppercase letters, digits, and you can either use the 2 characters hyphen or slash. Now the name must start with a letter and end with a letter or a single digit. So for example, we could type in IBM PC. Now under the operating system field, this identifies the operating system software used by this host, and it follows the same naming convention as the CPU field. So in keeping in line with the RFC, a valid CPU name would be IBM PC, and a valid operating system name would be Win32. And then we click on OK. We just click Done, and we can see the record that's been created here. So in other words, now if we were actually largely using this hinfo record, we could actually search for certain PCs based on the operating system and the hardware that they're currently using. Okay, we'll right click again, we'll go back to other new records, and we'll just scroll down a little bit and we see a few more. Next one we see is the IPv6 host record. Now this is one that you're probably going to become more familiar with as time goes by. This, well, 4A record specifies an absolute IPv6 address. Now it's supposed to be superseded by the record A6, which is going to be identified in RFC 1886. We'll choose Create Record, and we'll have a little bit of a look at what we see here. So what we'd actually enter is a host name of something. We'll call ours Server 02, for example. We can see the fully qualified domain name again gets populated. Now to give you an idea of what an IPv6 host address would look like, we're basically talking about something like this. Now if you enter an incorrectly formatted address, you will be prompted with a box showing you the correct information and correct format to use. So if we take this out and click OK, you can see that it's telling us that these are the correct formats that we need to use to create a correctly formed IPv6 address. So if we take that back out, and we'll repaste our other one back in, and we'll select OK, we can see the record's been created down here. Now I don't know about you, but I'm kind of not looking forward to having to remember that. but I'm sure some wonderful new utilities are going to be in the pipeline very soon to make these easier for us to manage. Okay, so we'll go back and select other new records again, and we'll scroll back down. And the next one we see here is ISDN. Now ISDN is another experimental DNS record type, and it maps the domain name to an ISDN phone number. So we'll click on Create Record, and down here under ISDN phone number and DDI, we'd enter the ISDN phone number or direct dial in number, and this should be conforming with international telephone numbering standards. So for example, if we entered this string here, what we'd be looking at is the 1 would represent the United States, 212 would represent Manhattan, and then of course the remainder here would be the actual number. Now below we have an ISDN subaddress in hexadecimal. Now this is an optional string of hexadecimal numbers. So we'll click cancel on this one here, and we'll go to the next one, which we see is a mail group. In fact, we'll look at a few here in a group because they're all sort of related. We have mail group, we have mailbox, we have mailbox information, and if we scroll down a little bit further, we have renamed mailbox. Now I'm not going to go through and create all these records because in most internet email-based servers they only support the MX record that we've already looked at. But I'll give a brief description on each of these. The mail group record is used to specify mail group members, and there must be at least one mail group record per member. So each member mailbox must be identical to a valid mailbox record, which we see here. So the mailbox record maps a user mailbox to a host. The host must be the same as a valid A record already defined in the same zone. Next we have the mailbox information record, and this specifies the mailbox of the responsible person, and optionally a mailbox for errors for this mailbox or list. Now each mailbox must be the same as a valid mailbox record that already exists in the same zone. Then finally we talked about the mailbox, the renamed mailbox record. Now funnily enough, this specifies a renamed mailbox. This MR record can be used as a forwarding entry for a user who has moved to a different mailbox. Okay, the next one we had here was next domain. In fact, next domain, public key, and also if I scroll down, signature records are all part of DNS security, or as it's actually known, it's just DNS Sec. Now DNS Sec is a secure DNS protocol designed to prevent IP spoofing and protect data integrity. The DNS Sec implementation uses the familiar public-private key system where the administrator for the site generates a key pair for the secure domain. Now the private key is generally kept on the domain's primary master name server, and then the public key is published in a domain in a key record. Now the administrator would then sign the data record, the domain data record, to verify its authenticity, and then would add one of these SIG records which contains the signature for each domain record. The administrator then submits the public key to the administrator of the domain's parent to sign with proof that he is the administrator of that domain. The parent domain's administrator signs the domain's public key and then returns it. Now currently DNS security is not widely implemented for a couple of reasons. Now first, it places a greater load on the DNS servers by making queries much greater, and secondly it can bloat DNS packets out by 5 to 7 times in size. Now take note that even though we're talking about DNS security here, Windows Server 2003 only supports a small subset of the DNS security standard at this stage. So jump on Microsoft's website and have a look at where they're up to with DNS security, and take a good look at what's coming in the future, because there's no doubt in my mind that you'll have to implement DNS security in your environment sooner rather than later. Now the next one we wanted to look at here was the responsible person. This specifies the mailbox of the person responsible for the host or the domain. Now whereas a start of authority record defines a responsible person for an entire zone, this responsible person type makes it possible to identify the responsible person for individual host names contained within the zone. So if we click on Create Record, we can see that we would have to enter in a host name. Then of course here we can enter the mailbox of the responsible person and then some optional associated text. Now you can use this optional associated text record to provide some additional information for the responsible person, such as their contact number or their shoe size or whatever you really like. Now just remember, if you are filling in one of these records, the mailbox of the responsible person has to be a fully qualified domain name. So this means that you would replace the @ symbol in the email address with a dot or a period. So we'll cancel this one out of here, and then we'll look at the next one, which is the route through record. The route through record specifies an intermediate host that provides routing to the domain name of the record. Now this can be used by computers which are not directly connected to the internet or a wide area network. We'll create one of these records, and you can see that we do also have a preference value. Now this is used to set priority. So if multiple intermediate routing hosts are specified, like with an MX record, the lower values are tried first. Now for each route that you specify through a host, you will need to have a host or an A record in the current zone. So we'll click cancel. We'll look at the next one here, which is the text record. Now the text record allows you to associate any arbitrary text with a host name. Now some substandard implementations of the bind command do not actually support the text record, but what they do is they'll import a bogus record called uinfo, which does the same thing. Now they're often used to hold general information about a domain name, such as who's hosting it, the contact person, phone numbers, and so on and so forth. Now text records are informational really for people only, and they're not required for any standard DNS functions. Now you can have multiple text records for a single host name. So if we click on one of these here, we can simply see that we could enter in a record name, so we'll call ours server 01, and then we could enter in any arbitrary text about this. We'll click OK. Next we have the well-known services record. Now this describes the well-known TCP/IP services that are supported by a particular protocol on a particular IP address. The well-known services record provide TCP and UDP availability information for TCP/IP servers. So if a server supports both TCP and UDP for a well-known service, or if the server has multiple IP addresses that support a service, multiple well-known service records can be used. So for this record, we'd simply enter in a host, an IP address, the protocol TCP or UDP, and then the service that's provided by this host on this IP address using either of these protocols. That's fairly self-explanatory, so we'll click cancel. We'll move on to the final one we have, which is the X25. Now X25 records map a domain name to a public switch data network, or a PSDN, address number. Now any numbers used with this record should follow the X121 international numbering plan. Okay, so we've basically gone through all of these records here. Now, I've probably confused you more than anything else. In fact, you'll look at a lot of those and think, when am I ever going to create those? And in fact, you're probably right. A lot of them you won't. Now, the ones you really need to be concerned with, of course, are the one on your right-click menu here. Host, Alias, and MX record. They're the three main ones that you will create. Now, you're not going to create too many MX and Alias records in your organization. The majority of records you'll be creating, of course, will be host records. And if you take the time to have a look at our DHCP server videos, we'll even show you ways to have these records created automatically. So you don't have to waste your time mucking around with host records when you could be doing other things. Okay, so there you have it. In this video we took a look at quite a lot of different records you can create on your DNS server. Now of course the majority of the time the records will be either an MX record, a Cname record, or a host record that you'll be creating. But don't discount some of the other records that we looked at. Whilst I said that some of them are largely experimental, that's not to say that we won't be using them in the very near future. Certainly things such as an IPv6 host may very well become part of your network in the very near future.